Hi, everybody. Welcome to our AT webinar series. This is our one of our national presenter webinars, and you see my friend Chris Bugaj right there in the screen with me for NHAT Connect. I just want to give a little quick intro of our program, and then I'll give Chris the rest of the time, I promise. This is just like a 2-minute plug as we go forward. If you're not familiar with our program and you are in New Hampshire, we want you. Join us. We have a year-long training experience for your school-based teams to join, where we look at professional learning. It's a blended hybrid experience where there is some virtual, there is some in person, there's ongoing coaching and mentoring. There's things like this that come up, webinars that we run. And so this happens for the entire school year. So we are currently searching for teams for our 22-23 cohort. So if you're interested, the QR code at the bottom of the slide will get you to the form to fill out, or you can visit our website, which is nhatconnect.com, and that will get you the info as well. Another thing, if you are a New Hampshire educator, we can give you something for free. Notice the key, you had to be a New Hampshire educator, but if you are someone from New Hampshire, we can share with you the New Hampshire Assistive Technology Handbook that was developed by the Quiet Leadership Team, what we affectionately call the Purple Book. And we can send you a digital copy of that book to help you start to get a sense of what effective assistive technology services looks like for you in your school to meet the needs of your learners. And then finally, one more little plug we have coming up. If you're watching the recording of this and it's before May 4th, please join us. On May 4th, we will have our assistive technology vendor fair. We're going to do that in person this year in Concord. Location is still to be determined, but we will be in Concord. We have a couple of choices to pick from. We'll have vendors there. So equipment vendors, we'll have national and local AT professionals there to share their experiences. Our teams will be there sharing their experiences for this year. So a lot of opportunities for learning, open to anyone. So anyone at all can join. You don't even have to be in New Hampshire for that one. You can come from any other state you want to. So please join us. There is a QR code there you can scan as well. That info is also on our website. And then finally, that was my 2-minute plug. I want to say welcome to Chris. Chris is going to talk to us today about Coding Core, teaching language to users of AAC using coding and robots. And so without further ado, Chris, I turn it over to you. Welcome.
Hey, welcome. Thank you for that great welcome, Mike. I am going to go over here. I think you have to make me a host. I don't have the sharing screen property.
Give me a second and I will make you host.
While you're doing that, at the vendor fair that's coming up on May the 4th, may the 4th be with you, I think is what we say in us Star Wars fans. Do you know if there'll be any robots? There'll be any vendors that are selling robots or sharing their robots?
I think that's a great question. I think we could easily do that. So I think we will put that on for sure. And I will certainly be doing some cosplay of some kind, but it'll be completely AT related. I'm not sure what yet. Here, let me stop my share and see if that lets you kick in your share.
Yes, there we go.
There you go.
Okay. Okay. And are you seeing my screen?
I am.
All right. So you're seeing my whole presentation here, right?
Yep.
Do you want me to start the captions through Google Slides or?
The transcripts are running through Zoom right now. So we're all good. And when the recording gets posted, we'll have captions in it.
All right. Well, like Mike said, this is Coding Core, teaching language to users of AAC using coding and robots. There's a QR code so you can get the slide deck. And then the bit.ly is bit.ly/codingnh. So like coding New Hampshire, bit.ly/codingnh. That'll get you this slide deck, which has a bunch of hyperlinks in it to a bunch of different resources that I hope by the end you find is really useful and powerful for helping students learn language using AAC, using coding and robots. My name is Chris Bugaj, and I am the Assistive Technology Specialist for Loudoun County Public Schools. But I'm not a really big fan of that term, Assistive Technology Specialist. I much rather think of myself as an inclusive design facilitator, somebody who works with educators to design educational experiences that work for everybody. So that's the day job. And then on the side, I do a bunch of presentations like this, and I do a podcast called Talking with Tech. Talking with Tech comes out every week, usually on Wednesdays, and it's a free podcast. And the way it works is that almost every episode starts with a banter between myself and the other co-host of the podcast, Rachel Madel. Rachel Madel is a private speech language pathologist that works out on the West Coast of the United States. And then there's me in Loudoun County, Virginia on the East Coast. She works in private practice. I work for a public school, but we have this sort of shared philosophy around language development and using AAC. So we get together every week. We do maybe 15 minutes of talking about some sort of topic related to AAC. And then we usually roll into an interview with some sort of stakeholder in the world of AAC. Sometimes that's users themselves, sometimes that's family members, sometimes it's other clinicians, it's anyone that is working or living in that space. So that's the podcast, again, free resource. But I've also had the great fortune to write a couple books. The most recent solo book is called The New Assistive Tech, Make Learning Awesome for All, and that is published through ISTE, which is the International Society for Technology and Education. And then the other book that is a collaborative effort with Beth Poss, Karen Janowski, and hold on, I'll remember the last name. Oh, wait, it's Mike Murata. Yeah, the four of us wrote this book together called Inclusive Learning 365, EdTech Strategies for Every Day of the Year. And it's exactly what you'd expect. It's 365 plus strategies, one per day, one per page, really, with an introductory chapter as well that kind of sets up the whole premise of the book to help you march your way towards developing more inclusive educational experiences for the learners you're supporting. So that's that. All right, so that's me. Whew, that's a lot in a nutshell. Let's get into some language and some robots. So there's this quote from Robopocalypse called, "The true knowledge is not in the things, but in finding the connections between the things." And if you were here participating live, I would say, let's put stuff in the chat. We'll make this an interactive. Even after the fact, feel free to reach out to me back with all this social media stuff. If you're watching this after the fact, reach out and let's talk about what you learned, right? So when we think of AAC, or when I think of AAC, I really think of it in sort of four stages. The consideration of augmentative / alternative communication. And just in case you're like, wait, what is AAC? You're using a term here that I don't even know. AAC stands for augmentative / alternative communication. What that really means is any way to express yourself that is not using speech, like your articulators, your tongue, your voice. So that could be sending text messages. That could be like, probably the most famous AAC user was Dr. Stephen Hawking, right? Who you recognize might use a computer to generate language to express the thoughts. So one big part of that, considering that for the learners we support, is like, well, what do you need to know to consider making like the proper choices to put in place? So there's a consideration process, then there's the actual selection process. But today, what we're going to focus on, that's why the little Bitmoji finger of mine is pointing towards implementation. It's now, once we've picked the thing or things that we're going to implement, now it gets to the busy work of actually implementing them and teaching them. And then, of course, a part of any learning experience is reflecting back on it and looking back at what you might do differently and what you might improve for other learners and the one you're trying to support. Okay, so what is this with robots and coding and language? Well, I want to tell you that that's me right there. This is a picture of something that we're doing in our neck of the woods called Robots for Everyone. It's an initiative that we, I guess it really started this year. The seeds of it started in previous years, where we did some lessons where we brought in robots into learners with autism. Some learners that didn't have autism but were still using a communication device to learn language. and we started putting robots in place. In 2020, we our school district won a state grant called Robots for Autism. We were able to get some funding to put some more robots in autism programs, and then the pandemic hit just as we were delivering the robots. We got absolved of having to do anything with the grant because of the pandemic, but we said, you know what? Let's keep doing this. Like, this is good stuff. Let's just do good work with it. So you'll see me, that's me on the floor in a preschool, early childhood, special education classroom. This is a coding app where you essentially drive a robot around. Down here, you can see we've been playing with the robot. It went underneath the cube chair here and kind of got stuck, and we're going to figure out how we can get it out from underneath there. And then, whoops, and then you can also see here, that's one student who's using AAC. That's an app called Lamp Words for Life. And that student is giving directions to me about how to control the robot, right? And you can see the other students here. And of course, I put the emoji smiley faces over them, but I can guarantee you they were smiling. They were having a blast through these experiences. One of the biggest things that I think we're hearing all around the country, probably in New Hampshire as well, is that as we moved back into in-person learning, the learners we were supporting were not necessarily used to the routines and the structure of a school learning environment. So we saw a spike in behaviors that you wouldn't necessarily have expected before in this learning environment. But I'm here to tell you, when we put robots in place, we have yet to see everyone was having some sort of on-task behavior. They weren't off doing, they weren't having any sort of negative behavior or negative correlation with the robots, because we were just having fun with them, right? And that's sort of the name of the game here. So, and it wasn't just fun for the learners, it was great for the educators that were supporting those learners. They all had a blast with it too. All right, so let me set the stage here a little bit for why robots and what do you mean coding? But Chris, don't you know the students, I mean preschool students in coding and robots, doesn't that feel like that's something way off? Like, can we teach them some other stuff first and then they can get to coding? And so I want to give you some principles to hang your hat on here to dispel that myth that coding and robots is something separate. So here's where we're going to start. We're going to start with a concept called the least dangerous assumption. So the least dangerous assumption is an article written by someone named Anne Donnellan, and then it was expounded upon by someone named Cheryl Jurgensen. And then I got to make this video that sort of explains some of my takeaways from reading their articles. But essentially what it says is that when you don't have enough information to make a good or informed choice about the type of intervention to put in place, choose the option that is least dangerous for the individual. What's the least dangerous assumption? And so the least dangerous assumption here is, yeah, maybe preschoolers, maybe people, maybe autistic people or people with autism, maybe we can, at a very early age, we can teach them to code. We can teach them to use robots to help them learn language. And so that brings us to the American Chopper guys here, right? Universal means everyone. Yeah, but not those kids. Now, what part of universal don't you understand? It can't be done. We can't teach them coding. Well, if you believe that, if you don't think they're going to learn language, if you don't think they are going to learn coding, and you're the one meant to support them, then they won't, right? Or it'll be much harder for them to do it because they'll be doing it in spite of you rather than because of you. So we start with the least dangerous assumption is that, yeah, we can do this. We can do this. And we can teach them language on their AAC device. The robots and the coding can help us help them learn that language, right? Okay, there's another scientific principle here at play, and this is something called the Pygmalion Effect. So the Pygmalion Effect, we're not going to watch the videos here. That's something you can go back and watch on your own. But the Pygmalion Effect, what that is based on some research that was done by someone named Rosenthal. So I'm going to give you the Cliff Notes version of the Rosenthal experiment. But essentially, he took these albino lab rats, right? Like you've seen in movies and stuff. And he took 2 sets of them and he put them in mazes. And the mazes were exactly the same. The only thing that was different was that there was a sign over one maze that said, these are smart rats. And then a sign over the other set of rats that said, these are maybe average rats, right? So the only variable is that sign. And then the graduate students or whoever it was that were sort of charting how fast the rats could get through the maze. So just let's pause there and reflect for a second. Which group of rats do you think got through the maze faster? Was it the ones that were labeled smart rats, or was it the ones that were labeled average rats? Which one do you think got through, or was there no difference because they're just the same rats, right? So I'll reflect on that for a second. Here's the answer. The answer is the ones that were labeled the smart rats actually got through the maze faster. The only difference was that sign and the researchers thinking these were smart rats, right? And this was replicated again with actual students, like actual learners in a school environment, where our perceptions of somebody can actually impact their outcome and their abilities. Not even the words we use with them, just our belief of who they are can impact, and what their abilities might be can impact their outcomes, which is why it is so imperative that we embrace this notion of the least dangerous assumption, right? That they will learn it, we can teach it, right? All right, so we're not going to watch that video. We're going to move on. So sum it up in 3 words, Chris. Okay, yeah, believe in the students, believe they will, right? Believe they will learn whatever we are going to set forth to teach them, and have super high expectations for what those might be, right? Okay, but believe they'll do what? When it comes to coding and robots and language, believe they'll do what? So in speech language pathology circles, and those that are using, they're attempting to teach language using AAC, we have a phrase that we used, and that's called SNUG. SNUG is, what it stands for is spontaneous novel utterance generation, and the term was coined by Dr. Katja Hill. And what it stands for, spontaneous novel utterance generation. So what that means is when you generate some sort of sentence, right, it comes off the top of your head. It's not pre-scripted necessarily, right? That's not to say we wouldn't use pre-scripted phrases as well, but what we're shooting for is teaching someone the ability to say whatever they want to say, however they want to say it, whenever they want to say it, to whomever they want to say it to. And this wouldn't be something that is necessarily pre-thought out. It just is coming off the top of their head. So for instance, if I said, let's do a quick sentence. Robots are fun, right? Well, okay. Was it spontaneous? Yes, I didn't know what sentence I was going to pick. Did I utter that sentence? Yeah, I said it. But here's the question. Was it novel? Have you ever heard anyone else say the sentence, robots are fun, before? You probably have, or someone probably has said those words in that order before. So in that example, I didn't pass the SNUG test. That phrase, robots are fun, does not pass the SNUG test. To be truly novel, it would have to be combining words together in ways that, well, like this. How about if I said something like this? Robots that have purple polka dots on them and that were given to us by a group of aliens who look like unicorns, found that we really had fun putting them in place, right? Now, you were probably following along listening to that sentence, and the way those words came together is probably the first time in the history of the planet that those words were ever put in that order, and it still made sense, right? Sort of. You could kind of picture the story as it was happening, as it was unfolding. But chances are no one will ever put those words in that same order again. And if I have that ability and you have that ability, then why wouldn't we? Again, the least dangerous assumption is to think that we could teach someone else to have that ability, right? And we can use the AAC and the robots and the coding to get there. All right, so we're going to work towards snug, right? Being able to believe they'll be able to say whatever they want to say, however they want to say it, right? That means we have to focus on language, and I'm building up to coding here. What are we getting? Where's the coding in the robots? Well, it starts with this. It's not really about communication. It's about teaching someone language, which means we're teaching somebody lots of words, and we're teaching them little parts of words, or like the ing or ly or ed at the end. We're teaching those, and we might be also teaching them how to put it in, well, definitely teaching them how to put it in multiple orders, put those words in different orders. That's language, right? And it's a shared set of rules, right? It's why if you're listening to me now and you're an English speaker, we can you can understand what I'm saying because we have a shared set of rules, right? Okay, so that's language. Also, when we go and teach AAC, when we teach language using AAC, we primarily focus on a set of words. Like if we have to teach all of these words to people can say whatever they want to say, that's a lot of words. So how do we dissect that? We've primarily focused on teaching core vocabulary words, meaning if you were to record any conversation anywhere in the world and you were to go back and listen to that conversation between anybody from ages 2 to 102, any conversation, and you jotted down all the words that were spoken in that conversation, you'd find that about 80% of those words are made up of the same set of 300 to 400 words. Let's call it 350 words. So if you could teach those 350 words, you get somebody 80% of the way there, right? So that's why we focus on core vocabulary. And what is core vocabulary? It's mostly verbs and adjectives, like verbs like stop and go and play and eat and turn, right? So verbs, pronouns, I, she, he, they, them, it, adjectives, big, blue, green, small, heavy, right? All those might be adjectives. What we typically don't focus on, not as much anyway, are the nouns. Nouns are typically what we call fringe vocabulary. So this quick little visualization sort of gives it to you that we have so many more fringe vocabulary words. Just think about all the millions of words out there. Most of them are nouns. They're persons or places or things or ideas, right? And so they make up fringe vocabulary. Core, just a small set of the millions of words. If we could teach them these 300 core words, 300 to 400 core words, we get them. This is how we actually use it. We get them a lot farther. We get them maybe 80% of the way there. So here is this, on this side, you see that the usage frequency is a lot higher for core words than we use fringe words. Like the word robot is a fringe word. How often, you all know what it means, but how often do you actually say the word robot? Even when I have a robot and I'm referencing it, I probably don't even say the word robot that much. I say stuff like, ooh, look at that one. Oh, get it. Oh, it's looking up. Oh, I turned it on. And I could have a whole conversation about a robot and never use the word robot. Look at it go. Okay. And then the last component here is let's have fun, right? We want learning experiences to have fun where kids want to be there, right? And the educators who are supporting them want to be there, right? So here's a quick question to ask yourself, again, to reflect on this question for a moment. I'll take you back. It's March 2020, and the schools are shutting down. Everyone's going to emergency distance learning. During those, let's say, first 3 months from March until June-ish, during emergency distance learning, what did kids miss most? And then if you were still distanced the entire following year and you were doing remote or distance learning, what did kids miss about the in-person learning experience? Well, if I were to click on this answer garden here, I'll do it. What you'll see is that what most people say is, come on, they're friends, right? They're friends. Look at friends, socialization, it's being in person with their friends, right? They miss their friends. there's some people that will say like classroom structure, or maybe some direct peer interaction, but that's their friends, right? So socializing with their friends, you can see it's a constant theme, and maybe it's even what you thought of when this question was reflected to you. So here's the question: if that's the case, that they miss their friends, then we don't really need school. We just need slumber parties. We just come over to a slumber party, or do after school sporting activities they can be with their friends, right? What is it about the school experience, being in that actual building, that's important, right? This slide is meant to represent every school board or superintendent across, I guess, the let's say the country. We're saying our preference was 100% in-person learning. We want to get back to in-person learning. We want to get back. And so this had me ask myself the question, why? What was so great about in-person learning if we can do the socialization another way? What is it that we're actually trying to teach and instruct in those educational spaces? And what can only be done in a building? So here's some thoughts about what those might be. Here's a few ideas. One, like it was referenced on the answer garden little visualization that you saw, is that being with peers, and being with peers as communication partners. So one way that you teach someone to use the AAC and learn language using AAC is for them to see other people and experience other people using the AAC that they're using. So this means inviting peers to also touch the communication device and model language using the communication device. And that's really hard to do in a distance learning setting. It's kind of seated around a book or a YouTube video or whatever, some sort of experience. Now we can have a shared iPad next to each other, or whatever the communication device might be, and we can be sharing it and using it together, having a shared experience in person with the peers as communication partners. And not just the same age level peers, but maybe older peers that were coming in, right? So many of you might be familiar with like a reading buddy program where you have, the fifth graders come down to the second graders and they buddy up and they read to each other, right? Well, that same thing could be happening with communication devices. Let's come down and play with the communication devices and talk with the communication devices. And those same things can be happening with robots and coding experiences. And then something else that I think many people didn't have, they don't have 3D printers at home, as an example of something. Oh, there's certain technologies that are available in the school building, like maker spaces and 3D printers, that most people don't have at home. So yes, I could design this birdhouse. This birdhouse was designed by my daughter. She could do that at home, but where was she actually going to print it? She's going to go to school and print it and send it to the printer there and actually get it and pull it off the printer and actually hold it in her hand, because, well, we actually do have a 3D printer at home, but most people don't. Okay. And then where are we going with the robots and coding? Robots is an experience that most people don't have at home unless it's their vacuum, right? There's the vacuum robots, but beyond that, robots like this or the other ones that I'm about to show you in this presentation, most people don't have at home. So man, I want to be at school today. I don't want it to be closed. I don't want to have a snow day. I want to go there because I want to be there because I'm going to play with robots, man. And it was going to be so much fun. And now I can't go because the snow's here. Oh, I don't want the snow. Instead of being celebrating snow days, we're lamenting them because they want to have these experiences. Okay. So you also might be thinking, okay, yeah, okay, I don't have robots and I'm focusing on IEP goals and other academic goals and other standards. What's the impetus for me to do this in my learning space with the learners I support, right? And here's the thing. Many states, and I don't know about New Hampshire, but many states have adopted computer science standards in the same way that there's reading standards and math standards and other types of standards there are now computer science standards. And if we were doing this live right now, if you were here, I'd ask you to, and you could pause right now, pause the video, go back, click on this link, and fill out this Google form that asks you, go Google it in your neck of the woods. If you're watching this from New Hampshire, does New Hampshire have, do they have state standards related to computer science? I bet they do. A bunch of people have done this experience before, and you can see all the different states that have computer science standards, right? And sometimes like Georgia's on the list here because they have it listed in multiple places where they found the information. So go look it up and see if New Hampshire has computer science standards. If they don't, they will someday. Virginia was the first back in 2017. It's coming. It's coming if it's not already here. All right. Now, what does language and AAC have to do with coding and the robots, right? Besides it being sort of like a, Chris, you said it was a fun experience. Besides it being fun, what's the deeper connection here, right? Well, what language is communication made up of shared rules by encoding meaning to consistent actions. I'm encoding meaning to the sounds that are coming out of my mouth, right? When you hear me say go, there's motor movements happening with my tongue and my articulators, my vocal cords, my tongue, my jaws, or my jaw, my lips. It all happens in a very consistent way, go. And that has a meaning that you understand, right? Well, that's exactly what coding is putting things in a certain order. And if you change that order up, it changes the meaning. Just like if I said got and I changed it, now I have a different word. It doesn't mean go anymore. I changed the order. If I said, let's put some words together. I go swimming. Or if I changed it around and I said, I want to go swimming, I added different words in there, it changes the meaning. I am building a code that you are understanding with with the sounds I'm making and the words I'm using. And when I put them in a certain order, that meaning is conveyed to you, and that goes back and forth. Well, coding is the same thing. Someone is creating a series of commands that follow in a certain order, and if you move those things around, it changes what the commands are and what actually happens at the end result of the code. So let's look at examples. Okay, so let's just dive in and look at examples. This is called block coding, and what it is puzzle pieces put together that when you put them in order, and you hit like a play button, or in this case, it says when the space bar is pressed. So if I hit space bar, it will follow the series of commands and it will go to an object, and that object will follow those commands. So I think I'm going to show you an example here. And this is something it's called the Hour of Code, but I have it linked here in the presentation. Let me just show you right here. Here's the website, code.org, Hour of Code. But one of the experiences they have, sort of early block coding experiences for people just starting out, is one based on Star Wars, right? So it says here, add a second move right command to your code, then click here to run it. So what we've got is this avatar of Rey from Star Wars, and she's giving BB-8 a command. We need the scrap metal. This is that icon for scrap metal. BB-8, can you get it? I like that it's got immersive reader, build right in, so you can click on that and it'll help you read this stuff out loud or segment it out if you want. But how do we get BB-8 to move to get to the scrap metal? Well, when I hit the run button, BB-8's going to move one space to the right, but it looks like it's 2 spaces. So let me just drag this over and hit run. Awesome. We did it. And look, I can show the code. This is what it kind of looks like in code language, but we're using the block coding. It says, want to keep playing? Yeah, let's go on to number 2 here, right? So here's the Star Wars music for you. Mute it though. Okay, so same thing. We need more scrap metal. Can you get all the metal in this area? So when I hit run, BB-8's going to move 1 space. I need it to BB-8 to move 2 spaces, 1, 2. Then I need it to move down 2 spaces. So let me put that there. And if I hit run, hey, I did it, and I did it, and look, I successfully achieved my objective and I followed the code. If I did it wrong, if I here, like I have to get these two, and let's say I moved it down and then move it to the, so I'm down and then left and then right. It's going to follow those directions. Uh-oh, it didn't work right. And I can go back and I can repair what I did. I can look at what I did wrong and I can reflect on it, work with a partner, and I can fix it. Okay, so what does that have to do with language? Well, first thing is take a look at some of the words just used here on the block coding. Move, up, move, down, left, right, when, run. All of those are core vocabulary words. That's why I spent so much time explaining what that was. Those are core vocabulary words. And what you're going to find is that much of the block coding, most of the block coding, and in any of the different programs we're going to look at, has core vocabulary at its core. So you can use that. Right? But then also on a deeper level, besides just teaching what these words mean, okay, I don't really know what move means. I got to teach, someone might not know what move means or know how to use it. We got to teach them what move means. So how do we teach them? Well, this could be a great way of teaching. Look, BB-8 is moving in a certain direction, up, down, left, right. Those are all other language concepts and terms we could be teaching using a program, a coding program like this. And then the deeper level, of course, is that language and coding go hand in hand, that they're the same thing. So you can make the analogy when someone will use requesting. When someone says, I want to eat that apple, right? Someone might give you an apple. But if you said, I want to throw that apple away, you might throw that apple away. And you'd be like, wait, that's not what I wanted. I wanted to get the apple. Okay, something broke down and I need to repair it. Same thing here. Something may have broken down. I need to repair it. Putting words in order, it shows putting commands in order, putting words in order matter and result in a specific meaning. All right, so there are other examples on this. So if you're like, well, Star Wars, who doesn't like Star Wars? But that's a great early one. There's also a Frozen one, and then there's others at this website that you can go explore. That gives you the basics. You can see it's not that complicated to just drag puzzle pieces around. Because when you hear the word coding, you might think like it's super complicated. Well, it can start off very basic. And that's where you could see those early childhood students, early childhood learners, even just putting things starting to sequence things. That's how language works. It's sequencing things. So that's a basic one. Now I'm also going to show you something called Scratch. Okay, so Scratch looks a little more complicated. I'm just going to bring you over here. So Scratch, the way it works is that Scratch, again, free website, and it has all these different commands that you can have. And what you're doing is you're commanding sprites. So sprites are the names of the objects that you might be moving on the screen. In this case, the default one is this Scratch the Cat avatar. But when I say, let's see, so I'm going to start with when the green flag is clicked, I want it to play a meow sound, and I want it to move 10 steps. And again, look at these words: move, turn, go, to, glide. Okay, that's a little fringy, but set, change. Most of these are core vocabulary words. I can have it say play a sound. I want it to say hello and think. Okay, so I'll do more. You can play with those on your own, but you can see you're just freely creating something here. And when I hit the go button, look, I think I have my, yeah, let's try it again. So move 10 steps. You see it's just moving just a hair, but that's what 10 steps are. So you can change that. You can change, I can make it 100 steps if I wanted. Right, and let's watch it again. See how much further it jumped. But again, this is all block coding is. It's dragging these puzzle pieces around and putting them in a particular order. All right, so you can do all that. That's, like I said, that's free stuff. And there's other ones that you could look into. These are also free. I would start with the block coding if you're first getting started. But if you have some learners that have been doing block coding, they might be ready to move over to actually typing out text and getting into more sophisticated coding. But you can easily start with just some of these. So this would be a moment to maybe pause and go play with Scratch or play with the Hour of Code, the Star Wars, and just kind of motor yourself through it and see how you can play with it. Okay. One other thing we can do with block coding is I'm going to show you this example. So this is example of two learners, one of them named Tucker, the other one named AJ, two best buddies who were in a coding class together. Neither of them, as far as we know, have a disability, but they were challenged. Instead of making some sort of video game or, I don't know, making some piece of code that doesn't really help anybody to learn how to code, they were challenged to, hey, we have some friends that are learning what the word go means. Can you create something in Scratch for an authentic purpose? Teach something. We need you to create something. Could you create something in Scratch to teach what the word go means? And this is what they came up with. So they came up with, here. So it says, press the green flag to activate space, right arrow or left arrow to see what the word go means. So let's press the green flag. Let's make it full screen. All right, I have to space bar. I hit go on the space bar, and what happens? Okay, it says go, and then a ship comes across the screen. But it said I could also do a right arrow, so I do a right arrow, and when I did right arrow, it said go, and an airplane comes across the screen. These were sixth graders making something out of Scratch for an authentic purpose that we could now, what they've created is like a simple game that we could, again, have preschoolers play, they could bring down in a sort of a buddy sort of system. They can also be sharing what they created, but they're motivated to make something because they're helping other kids. They're not just making something to make something, right? So that's another way we could use coding. I want to give a quick shout out here to an Apple product. So this is called Swift Playgrounds. It's a free app that you can get. And it also starts at the very basics of coding, where you move this little dude around these little sort of islands, right? The reason I'm pulling this one out and saying it explicitly is because this is on an iPad has something called voice control. And voice control, when you turn it on, puts these little flags over many of the operations that you would press. But now you can use your voice. So if I were to say, if I was working with this app and I were to say 11, it would unmute the sound, because right now it's currently muted, right? And then if I said 11 again, it would remute it, right? If I wanted to run my code, I would say 20, right? And why is that important? Well, we tested it, my friend Jane Odom and I, when voice control first came out and we knew about Swift Playgrounds. We tried it with various AAC applications, and the voice control, the AAC could be used to control the voice control of an iPad, meaning even if you had somebody that was an AAC user and they were trying to learn how to code, they could do it using their AAC device, even if they didn't have the full ability to move their to slide things or slide the block coding around or type in the text. Okay, so takeaways, moment of reflection. Block coding is mostly core words. Coding is language and language is code, right? When I do something, this thing happens. When I do something else, this other thing happens, right? When I say something, people do stuff. When I say something different, people do other stuff, right? My words have power and people learn that over time, just like coding. And then these sorts of experiences, when you say the word like, oh, I'm a coder, sometimes you get this impression of someone in a dark room eating Cheetos by themselves, right? But that is not at all how it works. It works, people who are coders work in teams and they work with people who they're trying to generate code for. So there's they're in constant communication with each other. They're constantly collaborating. It's a very social experience to actually code anything. So you don't have to work in isolation. You might think coding is isolating, but it's not. It's something you can work collaboratively. And of course, it's fun. It's fun. All right. So we were talking about robots, right? We've got about 15 minutes left. we're going to talk about robots in these 15 minutes. So first, I'm going to go through a couple. Now, these are commercial products, and I've been showing off this robot here in the camera. This is called the Dash robot from a company called Wonder Workshop. And full disclosure, I won this at an ISTE conference, and that's how I really got to play with it. Some of our schools had them, but I didn't really take the time to learn them or play with them until I won it at ISTE. And then I did, and it's, again, the same block coding sort of applications. You drag things around. When you hit a certain button, it'll follow those commands. It'll go a certain, if you told it to go a certain number of spaces, it'll go a certain number of spaces. If you told it to turn, it'll turn. If you tell it to turn its head up, it'll turn its head up. It'll look around. It'll play sounds. You can record sounds in it, all sorts of fun stuff. Oftentimes, I've been doing this presentation quite a bit recently, and what we find when I'm talking to people about this is that they like, oh yeah, I've seen those. Or some of the learners that have been in the experience have been like, oh yeah, we have those at my school, right? Some learners have seen these before, but we haven't necessarily been using them to teach language or putting them in programs or in inclusive settings where there are students who are learning language using AAC using them. And so check it out, check out your school and just go ask. Sometimes they're hidden in the library, or if you have a technology support person, it's like, do we have any robots? Because chances are you may have purchased some in the past. So this is one, like I said, there's the Dash robot. There's a couple others. These are called the Q. They're a little bit more sophisticated. There's a version that's just a head. Those are called the Dot robots, which is a little less expensive. And I'll let you check out the costs and click on the links and see if you're interested in getting a robot. Maybe this is something you want to consider getting a grant for if you don't have any. All right, Cubelets. Cubelets are a different sort of robot. These are like individual blocks, right? They're like blocks you play with when you're a little kid, except these blocks, each one has a different function. Some have different lights, others have different sensors, some have wheels, like you can kind of see down here at the bottom. So you can put it, and they have magnets, so you put them together in different configurations to make robots. And one of the reasons some of the educators that I work with like these is because they are very much using your hands. OTs rejoice, right? You're picking things up, you're snapping them together, you're actually playing with your hands, where sometimes when you're doing the block coding, it's using a screen, right? You're dragging things around on a screen. All right, Ozzobots, also very popular. These little guys are about the size of a golf ball. And what they have is a little sensor in the front that picks up colors. So what people do is you take a marker, like a Sharpie like this, and you draw a line, you put the Ozzobot on it, and it follows the line. Again, OTs rejoice, teachers rejoice, because you can draw pictures, you can do letters, and they'll follow the black line, and the robot can follow the line. Now, it's more sophisticated than that, because the Ozzobot is already programmed to, when it hits a certain pattern of colors, so imagine it's a black line and suddenly it gets to a red, yellow, red pattern. That might tell the Ozzobot to spin like a tornado, or if you are drawing a line and then you divert, the path diverges to the right or to the left, you can set up a series that say, if you see this blue, yellow, blue pattern, go right. But if it's a green, red, green pattern, go left. And it commands the Ozzobot to go in a certain direction. Great for working on colors, again, for those fine motor activities. Sphero is probably the most commercially available, the one people have heard about the most. They probably even seen this someplace, but also has great educational purposes as well. It's what the actual BB-8 in Star Wars was built on, was a Sphero. Lego Education has a bunch of different coding applications. The one that's pictured here is something called Lego Mindstorms, but they have that's an expensive one. They have, and it looks pretty sophisticated. They have a whole range of products that you could look into for coding and robot creation. Right? All right, all of those though cost some money, right? And this one does as well. This is called the B-Bot. And what the B-Bot does is, you can see it has actual physical buttons on shaped like a B that you actually push down to give it directions. So the whole time here, you're like, Chris, I don't have money. I don't have a grant. I don't have these robots. Show me something I can actually use. So I'm going to show you. So the Bbot has an online emulator, which allows you to do all sorts of different activities, again, or experiences for free. I have right now, it's called the Alphabet Mat, but you'll note that there's a bunch of other ones here. Let's say I was working on coins, right, and money. I could have the coins mat, right? If I was working on CVC words, I could have CVC words mat, right? So find me something that ends in, here, we'll go back to the alphabet. Mike Murata is our host today. Let's say I was trying to teach him to spell, and we might say, okay, how do we get this robot over to his name for Mike, right? So we're gonna we're gonna go up 1, and then we're gonna turn, and then I'm gonna go forward 1 more, and watch what happens when I hit go. Yay, we got to the M, the first letter in Mike's, right? We can scale that up or down by saying, okay, how could we get to spell out his name? So it would go to the I next, and the K next, and the E finally, and ending on an E, right? So you can see that there's, just erase it and start again and do one of these other activities. So even if you don't have a robot, you can have a virtual robot that you're playing with, right? Look at the core vocabulary there, go, stop, turn, you did it, you found it. And then practicing spelling on the keyboard as well, on the AAC tool, great way to practice early literacy. Okay, that's one, but there's another robot. Now these are called iRobots, the root robots. And these are actually from the company that makes those, well, at least one company that makes those vacuum cleaners. But what they have is a whole set of online activities as well, also for free. I'm not signed in here at all, right? And even if I was, I didn't pay for it. So here it's a code a letter challenge. Let's stick with this theme of learning letters, right? So it's here, draw a P, right? So there's my little virtual robot. And here's my commands. So I want it to draw a P. I want to drag that up there, and it's going to go 1, and then 2, and then I need it to turn to the right. Whoops, I want to put that here, right? And then I need it to move forward again, right? And then I need it to turn to the right again, and then I need it to move forward again. And then, so we won't do the whole thing. Oh, but look, what's this pen mean? Well, I think it needs to lower the pen first. All right, let's see what happens. The pen goes down. Oh, I got close, but I didn't finish out that P. You see how, again, I'm putting things in a series of, in an order that is, again, if I messed it up, I can go back and fix it, and I can repair it. So those are 2 free robot emulators that you can check out on your own. And then I just want to kind of wrap up with some sort of last final thoughts here are, 1, there are organizations that can help you do this. The Black Girls Code and Girls Who Code are 2 that I'm familiar with that have existing programs, so you can already partner with them and say, okay, look, I need a little help getting my robots initiative, or even putting a robot in place or coding at all in my into my educational experiences. These are organizations you could buddy up with or partner with. And if your school doesn't already have a club like this, maybe this is your thing. Maybe this is what you start, and you sponsor your own version of this. Okay? This Jamboard here is meant to ask you some reflective questions, to be thinking about what comes next, right? What goals could you be addressing using these robots? How might you fund the acquisition of robots? I mentioned grants, but could you go to your PTO or PTA? Is it something you want to buy on your own, right? Where else can you fund the robots? How do we support the robots at home? Well, if we've been playing at school, how do we carry that over so parents can have that experience? Well, certainly these emulators are an idea there. But even telling stories about the robots, taking pictures, then putting them in a tool like Tar Heel Reader to make a story, or Book Creator is another tool to make a story. And now those go home and now we're sharing the story together. That could be a great home experience. And then how might you collaborate with, or who might you collaborate with? Is it something where you buddy up with another related service staff, like an occupational therapist or a physical therapist, or say, hey, why don't we try this with do you have someone that's doing this already? And you can say, hey, can we try this with the students that I'm working with? Okay. So those were meant to give you some little moments of reflection here. But just to give you a plan of action, a plan moving forward is choose one or more core vocabulary word to teach, like play, like turn, like go, like stop, like in or under, we had ours go underneath kids' legs and they were laughing hysterically as the robot went under them. Or down, we would put different markers, like just stand up a marker, like, okay, see if you can knock it down, knock down the blocks, and the kids are using the commands to try and knock it down. Oh, you missed it. Oh, so close. All those are great core vocabulary words. Or you did it. It went down, down, down. You knocked it down, right? All those are great core vocabulary words and great experiences and great fun, right? Bonus points if you can tie it to a computer science standard in your area. If your state has, if New Hampshire has computer science standards, then great, because the very early computer science standards are like sequencing and patterning, and it's very similar to what we would need, what those foundational skills are for learning language. Right? And then what other goals? Maybe the robots, I should say this explicitly, I would not want you to use the robots as an incentive, like, well, first do this horrible experience and have a horrible time, then you get to play with robots. It's not that. It's let's replace that horrible experience that the learners are not wanting to do and think, how can we incorporate the robots so it's more fun? So imagine again, I don't want to do my letters, right? And that's maybe I'm having an adversive reaction to having being expected to do my letters. But wait a second, what if we draw letters with the robots? Now we're still learning our letters, but we're doing it in a fun way. So what other goals might be addressed beyond just language? Again, how can it be reinforced at home? And then thinking through, if you don't have them, you could start with some of these emulators, start with some of these coding, these free coding apps to try, but then as you work towards, how are we going to get these into our learning space? I think that's it. There's some last little things here, I guess, to finish up with is there's a Google form here that you can use to kind of guide your thinking. And I've shared the responses so you can see other people that have sort of made a little bit of their own lesson plan, their own design of how they're going to move forward. Here is one of the Talking with Tech episodes that we did, where a bunch of us got together and just sat around and talked about the different applications of using coding and how it could be used to help teach language. And then you can get some more stuff. We have newsletters that you can sign up for, where you can get more information about this and other inclusive strategies that we talk about in other presentations and beyond. So I think we'll leave it there. This is a blog that I help write. So you sign up for this blog, again, free, and we share a lot about what we do with robots and coding there. And I think that brings us to time, right at an hour. Thank you for spending your time with me. Please let me know, hit me up. Let me know how it goes with those robots. Let me know how it goes with the coding. Let me know if you, with your triumphs or tribulations, reach out. I'm very eager to help and very eager to hear these stories. Happy to share. All right. Thanks, everybody.
Thanks, Chris. Appreciate it. It's such a great next step for people to use those emulators and the free programs. I always like, I liken this to like when you said it, the built-in accessibility features. It's this proof of concept. Look at the cool things we can do that are building skills and helping infuse language into experiences. And we did this for free. Now we could go even further if we had these other tools, and here's what we would do.
Yeah, for sure. And can't you just imagine some learner that you're supporting, right? They get the job at Google, they get the job at Apple, they get to create their own company. Maybe they're creating it because you started out at a very young age with the foundational skills of like just putting things in order, and sequencing and playing with some of these sorts of experiences.
Yeah.
I think it's really exciting.
Yeah, it's great. That aha moment. They had their aha moment that propelled them forward because of that.
I hope so.
Awesome. Chris, thanks so much. I appreciate it. Everybody, check out all those resources and look to our website for other upcoming webinars and recordings if you miss some. We'll post all the recordings on our nhatconnect.com website. So Chris, thanks again.
Thank you, Mike. Bye-bye.